Hello everyone, welcome back to my tutorial. In this tutorial, we'll solve this plate with hole model in quarter symmetry. So in last case, we have modeled with half symmetry. We have taken one half and we have solved it. We have got the same result. Now we'll be simplifying that half symmetry into quarter symmetry. We'll be taking one quarter and we'll be applying the boundary conditions in such a way that we'll get the same results. The symmetry application will reduce our model size into small to reduce the computation time. Now we'll solve this. Let's get started. Now I just open Salome FEA. So here I kept this file. Put this code to open. I'm using Salome FEA 2022 version. Now we can use the previous model. For that, just go to File, Open, Pictures, Code Aster. So the 7th case we can take it, and I have already put it in 8th case. So this is the 7th case study one HDF file. Then open it. Now just go to Geometry. So in last case we have created half symmetries. Now we'll take this model, we'll divide this model into two and we'll take top quarter only. Okay, for that just go to New Entity, Basic, Plane. We have already one vertices here. So on normal to y-axis, make it the size of the plane is 1 or plane close. Now use the Boolean operation or partition. I'm just going to use partition. So our main object is the solid 2 and tool object is plane, a plane close. Now you can see our model is divided into two. Now just right click this partition 2, go to Entity, Explode into Solid, a plane close. Now you can see there are two models, two solids. So now we'll be taking solid 4, this one. Now we'll create the boundary condition for this model and we'll solve it. So go to New Entity, Groups, Create Groups. Now we just want to apply symmetry boundary condition here and here. So this is normal to this surface direction is 0. Similarly, normal to this surface direction is 0. Okay. Now surface, add this normal to surface direction is, you can see this x direction, this symmetry of x, then apply. Here you can check the direction. This normal to surface is y direction, that means symmetry of y. We just want to fix in y direction only for this surface. So to complete constraint, we need to fix x direction, y direction and z direction. Now we have created two directions. If you are not fixing z direction, it will do degree of freedom error. That means it's not fully constrained. It will show that error. To avoid that error, we just want to fix this particular edge in z direction. For that, change this into edge mode. This edge, add, make it fix z. Now apply it. Now we have created three constraint boundary condition. Now we just want to apply a load. For that, select this particular surface, add this. Here we are going to apply load and apply and close. Now we have created all the groups for applying the boundary conditions. Now we can take this model for meshing. Now just save this model, go to geometry, mesh. In mesh model we have previous mesh. You just delete this previous mesh. This is we don't wanted it. If you want to keep, you can keep it also. So mesh, create mesh. Now same, use NetGen 1D, 2D, 3D. Use new parameter. This is just make it 005. This is make it 002. Apply, OK, apply and close. Now right click this mesh one, compute. So this is a mesh we have created. Now we just check the groups are imported here or not. So now the groups are also came here. Now we'll generate the command file for solve the code to solve in Codaster. Now go to here. Here this is the more efficient. This software we can download from Mooney's Engineering. You open JDK Java runtime. Select it. So now our model is 3D only. Just keep it this page same. Analysis type is mechanical 3D. Material we make it carbon steel 210 e power 9. This is make it 7860. Just put it all, add it. Now go to element type. Here we are using 3D element. You need not to specify anything. Go to boundary condition. Now you can check. So now we just want to fix symmetry X, symmetry Y and fix Z. So first one we'll use face impo. So symmetry X. This is we can name any name we can give. I'm just giving symmetry X. Apply to sim X. This has to be named same as whatever the group name we have created. This X has to be fixed and remaining Y and Z keep it empty and add. Now the second one is symmetry Y. Now just name it as sim underscore Y. Whatever the name, similar name has to be given here, and Y direction has to be fixed and add. Now the third one is fix Z. For that we have a mesh group, that is a edge group, not the node group. For that we need to use DOF mesh group, and boundary condition is we can fixed in Z. That is the name I am giving, and fix Z is the proper name we need to specify here. Fix underscore small z. Then Z direction has to be fixed and add it here. So need not to fix this drx y z because this is 3D model. 3 translation degree of freedom constraint is enough for that. Now go to loads, force on the face. Now we just want to apply here this force on the face, force on the edge. So force on the face, pressure, both the boundary conditions are same. Only thing is in pressure only a direction we can give. One is compression, tension. That is the only way. But force on the face is we can specify the direction. That is the only thing. So force on the edge means it will apply in Newton per meter. Force on the node means it will apply in number of nodes. So example 1000 Newton we need to apply means, so how many number of nodes we have here, that has to be divided. So now we are going to apply as force on the face. Now we can name it as load, assign to load. Here fx is 1000 divided by area. Area is 0.01. So this is the area. That means this is the pressure it's going to apply. This is actually pressure. This is the pressure value. 1 e power 6 it will come. We can keep directly 1 e power 6. Okay. Now add it. So Now we have added the load also. Now go to output, add all, save. Here we can save it as 8th case static 1.comm. Now I have saved it. Now we can exit it. Now go to here, pictures, 8th case. There is already a case, that is we can delete it. This also we can, this also. So this is enough. To avoid confusing, I have removed all the files. This also we can delete it. Now we can run the case. Now go to Salome meca, just saving this file. Go to tools, plugins, run ASTK. Now we can choose the location. This 8th case, okay. First one is command file. To specify this one, keep it aside. This is, you keep it this side. First one is the command static 1.comm. So this name has to be similar to this name. There should not be any change in caps and small letters. And second one is mail. This is one is message. This is this is we can resu, error, and RMD file format. Yes. Now this one is mesh file. Now we export this mesh file. So mesh file I have exported here. This mesh one. Now just specify it as mesh_1.mad. .mad. Now message .mess resu error.err result.rmd. So everything we have specified it. We can specify the memory of 2 GB, interactive follow-up. Now we can save this file. Save it as ASTK and saved it. So I have saved this file also. Now we can run the case. Run it. Now we can check the message file if any error comes. So here you can see now it is solved nicely. You can check result file. So there is no error. If there is error, here it will come. So now go to Paravis to see the post processing. Open this one, just OK and apply it. This is the quarter model. We have modeled it. Go to displacement. Here check with the dx. Now again go here, sigma, so here you can check the same stress. So the stress whatever we are applying here is 1e⁴. Whatever the stress we are getting is almost 3 times more than the stress. That is because of stress concentration around the circle. Similarly, we can check with the von Mises stresses. So here this is also same, similarly around 3 times more. To make the deformed safe, just go to displacement, wrap by vector, give some scale, apply it. So this is the way it will get deformed. To animate it, just go to right click here, create animation, 20 frames, give OK, just make it loop, animate it. So this is the way it will get animated. So thank you for watching my videos. Please subscribe my channel for more videos. Don't forget to click on the bell button for continuous updation of videos. Thank you.